go. So when we start making poly-MEMS devices, and poly stands for polycrystalline silicon, and MEMS is the multi-user micro MEMS processes. I think that's what MEMS stands for. You build these things up in the clean room, and you do it layer by layer by layer. So I started a few layers here. Okay, so you know, this is our silicon substrate right here. Okay, so we start with a bare silicon wafer. Okay, and usually we'll put some silicon nitride on top of it, and they actually have a little bit of silicon dioxide between the silicon nitride and the substrate, usually. Okay, the silicon nitride is a barrier layer. It's really hard. It's also an insulator, so you're trying to separate out the structures you're building on top of here from the substrate so you don't get any shorting or leakage, or it's electrically isolated. Okay? That's why we have silicon nitride. And we don't pattern that. So
insulator?
Silicon nitride's an insulator.
Okay.
In this case, we're using it as an insulator. We also use it as a membrane when we're making pressure sensors, and silicon nitride is used as a hard mask. So there's lots of uses for that material, okay? So really the first thing you're going to design in, the first layer, right, when you draw those boxes and stuff like you saw in the other lecture, the first layer would be poly zero. So what actually happens in the process in the clean room is you put poly zero on everything. And then you remove it from where you don't want it. So if you don't want any poly zero, right, you wouldn't draw anything on that layer in your design. So when they go to make it in the clean room, what do? They put poly zero down on everything. They take your mask, your poly zero layer, mask. It's clear because you haven't drawn anything on it.
Mm-hmm.
They expose the photoresist and etch all the poly zero away. Okay? It's a wasted step, but there are other people in other designs or other parts of the design where you want poly zero in that case. So let's talk about poly zero. We just saw in the previous short video that we made hole zero, right? Hole zero. So I'm going to make a hole in this. Hole zero is the layer. So you select that layer in your design software, and then you start drawing. So it's really funny. Whatever you draw in the hole zero layer will end up being a hole. Whatever you draw in the poly zero layer will end up being a structure. Okay?
I'm not sure what this hole zero layer is.
Okay, well let's talk about how you make a hole in poly zero.
Okay.
So the first thing you do in the clean room, okay, is you spin on some photoresist. So we're going to make the photoresist red. I'm going to make it a little bit wider. So we spin on some photoresist, and we all did that in the first Intro to MEMS class. We made our pattern, if you remember. So we spin on some photoresist. That's pretty cool. Now we're going to make a hole in that. So we got to have a mask, right? So I'm going to draw the mask up here. And it's represented by white, meaning it's clear. So it's glass. And then there's parts of the mask that will have chrome on it, which keeps the light from going through it. So in this case, we put chrome everywhere except one spot. So if I don't draw a hole, let's make this clear. Okay, if I don't draw a hole, then it's all going to be black. It's all going to have chrome on it. Okay? So the light's usually blue light, bluish green maybe. Let's make it greenish. So when we expose the photoresist with this mask, the light tries to go through the mask and get stopped where the chrome is. But where there's no chrome and it's clear, it goes through, right? Can you see that? And what happens when light hits the photoresist?
Exposes it.
It exposes it. Okay, so I'm exposing it. So those photons come through and they expose the photoresist. So the photons are absorbed by the photoactive compound, turns it into an acid in that region. A chemical reaction starts to take place, so this becomes acidic. Okay? Then we take it out of the exposure tool. All right? So we take it out of the exposure tool, the mask goes away. We're going to take it out of the exposure tool. We're no longer in the stepper or the 1X contact printer. Okay? But we still have this exposed part down here, right? Got exposed. Now we're going to put it in what? Developer, right? So we put it in some developer. This is a solution. Developer is acid or base? Remember? It's a base. Bases react with acidic things. So this is acidic, where the light hit. So what you end up doing is you end up dissolving this away. Maybe. Okay, now I'm going to take it out of the developer. Spin, rinse, dry it. Right, and now I've got photoresist with a hole in it. Okay, that hole is defined by your mask, by your drawing at that layer, at the poly zero layer. Okay, that's a hole. So now we got a hole in the photoresist. We usually etch poly in a reactive ion etcher. Okay, so we get ions of a certain type. We speed them up. They go flying around. Right? They bounce off of the surface. Okay, but when they get into here, they start to react with the poly zero. And you etch it away. So eventually, you eat away at the poly zero. Now you can do a timed etch, so you know how long it takes to go through a certain thickness. Okay? You can etch it all away.
So you made that hole just so you could etch the poly zero in that spot, right?
Yep. And I etched to the silicon nitride.
Silicon nitride stopped it.
Yeah, well, it usually won't etch silicon nitride because it's a different material and you set the chemistry up that way. Okay? So now I made a hole in my resist with the develop process, and I made a hole in my poly zero with the reactive ion etch process. All right, now what do I do? I have to strip the resist off, don't I?
Clean it up.
So that's called resist strip. So as a designer, it's an easy job. You just draw the box to make the hole and you're done. The poor guys in the clean room have to do all the work, right? So now I got a hole in there. Now what am I going to do? Well, the next layer after poly zero, we're going to put down some silicon dioxide. So the way you deposit silicon dioxide is you put it in a furnace. And then you pump some silane in there and some oxygen in there. Got to be real careful because silane and oxygen are pyrophoric and it goes boom if you do too much. So you leak a little bit of silane and oxygen in there and you grow silicon dioxide and it deposits on the surface. Okay, and it's conformal, so when it sees the hole, it goes and fills the hole up like this. Can you guys see that?
Okay, so why do we make a hole and fill it again?
This poly zero is now isolated from this poly zero. So I can put a positive voltage here and a negative voltage here and do things. Because they're not electrically connected anymore. Okay? So that's primarily the reason you make holes in the poly zero. All right, so I've got this conformal deposition of silicon dioxide. All right, now I'm going to put an anchor in here. Okay, the first anchor. So again, it's the same thing. You put photoresist on there. I'm just going to draw it in one place now. Okay. And then I'm going to pattern it like I did before and make a hole in it.
What is the purple stuff again?
Silicon dioxide.
Okay.
Good question. Let me label it.
And does that mean it's doped? It's electrical, or is it a better conductor?
Silicon dioxide is an insulator.
It's an insulator.
And we're using it here to do as a sacrificial layer to give you space between the other layers, so the layers can move relative to each other. So the purpose of the silicon dioxide is to give you space, and we talked about that in the previous cartoon lecture that's online. Okay, so I'm going to make a hole in my resist, then I'm going to etch it. Okay, the silicon dioxide now. Come on, etch please. There we go. I'm going to etch it away. Okay, and silicon dioxide is usually a wet etch because it's cheaper. You can do a dry etch with a reactive ion etch again, or you can do a wet etch with hydrofluoric acid like we did when we made our art wafers in Introduction to MEMS. Right, when we etched the silicon dioxide away. You guys remember that? I hope. Wasn't that long ago? Dustin's going to get to do this semester.
What's the hole going to be for?
Well, I want to connect my poly 1 to my poly 0.
That's what I thought.
So that's a beautiful question. So this is going to be an anchor. I just made my anchor cut.
Mm-hmm.
So that's when I draw the square in the software,
Mm-hmm.
that little black square. That makes that hole.
Mm-hmm.
So you're making the hole in the photoresist, and then that material underneath is exposed to the etch. Wherever the photoresist is covering is protected.
Mm-hmm.
Okay? And then, of course, we're going to go ahead and strip the photoresist. So now I'm going to deposit poly 1. Let's make it yellow just for the heck of it, even though it's red in the software. So now I'm going to deposit poly 0, right? And it's conformal too. Looks like a cantilever, doesn't it?
Yeah, it does.
Okay. Notice though, because of the topology of the silicon dioxide, this layer here, silicon dioxide, the poly 1 is conformal as well. So you made this little bump here, and then we anchored it over here. All right.
Mm-hmm.
So if you remember from the design lecture, you saw that little bump on the bottom of the poly 1 when it was on top of the poly 0 hole. That's why. Okay?
To prevent stiction?
No, that's dimple. We haven't talked
the
about
dimple.
that yet.
I'm looking at the purple dimple.
Yeah. There's no dimple yet in this.
Okay.
We skipped that.
That's just the
We skipped
connection.
that. We're just showing you how this works from a side view. Okay? We have not talked about dimples yet. Okay. So if I want to get rid of, if I want to pattern this, I do a photo mask, put photoresist on there, and I etch the exposed poly, and I'm going to just do that. Okay? And let me make this stuff disappear here. It's not really there. All right, so now I've got what looks like a cantilever, but it's not going to move, is it? We've got some topology here, some bumpiness. Okay, and that's normal. That's what's going to happen. Get rid of this label. So now we can etch the poly away. We can also etch a hole in the poly if we pattern it that way. Right? We can put a hole in it, or several holes in it. Now, why do we put holes in this stuff? Why would we want to put holes in poly?
So you can easily remove the silicon dioxide.
Bingo! Did everybody hear that?
To let the etching stuff go in there, or?
Yes. So if I have a hole in here, and then when I'm all done making my product, I'm going to stick it into a bath of HF, perhaps, and it's going to dissolve all the silicon dioxide, which is this stuff. Remember? This grayish, purplish stuff. So we're going to start etching it away. But it'll stop at some point. Now, if I have a hole here, it's going to start to etch in here, right? And then I have a hole here, it's going to help etch it away here.
So they just found this out by trial and error?
Pretty much. A lot of stuff is by, oh shit, it didn't work.
Right, what can we do?
How do we fix it? Problem solving, right? A lot of things are done that way. So it etches all of this stuff away. And now I have a cantilever. Now these holes here are just little holes, right? It's really connected.
Yeah,
We just
'cause
cut
it makes
through
me
it.
think like it's gonna float away now.
Yeah, it's not. These are really connected. I just happened to cut through it where the holes are. All right, but what's really cool, let me change colors here. Da-da-da-da-da. Oh, this purple salmon color is
So it's
nice.
connected, it just has some little tiny holes in it.
Right. So what's cool now is you've got this poly 0 here, and you've got another poly 0 here, this pad and this pad. I can put a positive voltage here and
Right.
ground it like we did in the last lecture, and then this will be attracted down, right, and it'll bend. All right, so we talked about these little holes in here, these poly 1 holes. Those are called release holes.
Okay.
They're also called release cuts. And that's to give a path for your hydrofluoric acid to eat out that sacrificial layer. It's sacrificial because we get rid of it, right? We sacrifice it. And it's silicon dioxide, so hydrofluoric acid eats that away. They also use hydrofluoric vapor now. They have a vapor system to do it. It tends to work a little bit better. Okay? So that's the whole thing about the holes. Why we put holes into our poly layer, our moving poly layers, and why we get bumps happening because of the conformal deposition of the layers beforehand. And it's kind of like snow, right? When snow falls, if I go to another layer,